Hello everyone. Today we're looking at angles of triangles. This is part one of a, I suppose, four-part explanation into 4.2, angles of triangles. Today we're doing notes on angles of triangles. Tomorrow there's an activity on angles of triangles. On Thursday we're looking at angles of triangles from an algebraic perspective. And then on Friday we're doing angles of triangles, algebraic assignments. So let's get into it. The triangle angle sum theorem, and I will have a link to the proof embedded in the physical copy of the notes as well as in the Schoology folder for you to see. But essentially, the measurement of angle A plus the measurement of angle B plus the measurement of angle C must equal 180, such that the internal area, the internal degree measurement of the triangle is equal to 180. So, keeping that in mind, example 1, find the measure of angle T, also known as find the measure of angle T. Well, our angle R plus angle S plus angle T must be equal to 100. So we could say, must be equal to 180. So we could say that 25 plus 35 plus, just call it T, must be equal to 180. Combine our like terms. 35 plus 25 gives us 60. 60 plus T must be equal to 180. Subtract 60 from both sides. T is equal to 180. Or if we're being more specific, the measurement of angle T is equal to 180. So guided practice. Find the measure of the numbered angles. That is to say, we want to find in number 1, we want to find angle P, measurement of angle P. And number 2, we want to find the measurement of angle S. Once more, the internal angles of a triangle must be equal to 180 degrees, so we set up our equations based on what we know. For instance, in number 1, we know that 62 plus 90 plus the measurement of angle P must be equal to 180. Combine our like terms. And me personally, because I'm doing it mentally, I don't like 62 plus 90, so I'm going to do something slightly different. I'm going to subtract 90 from both sides before I start combining terms. Because I know that 180 minus 90 is just going to be 90. So 62 plus the measure of angle P is equal to 90. And for me, mentally, 90 minus 62 is an easier thing for me to do. So the measurement of angle P is equal to 28 degrees. The measurement of angle S in number 2, well, we don't know, it doesn't label for us what R is, but we can assume based on the similar symbols on Q that Q and R are both the same angle measurement. So we can assume then that 30, the measurement of angle Q, plus 30, the measurement of angle R, plus the measurement of angle S, is equal to 180. That is to say that 60 plus the measurement of angle S is equal to 180. That is to say that if we subtract 60 from both sides, the measurement of angle S is equal to 120. Not that bad, right? Let's keep going. Example 2. We've got a triangle that's a little more complex, or a pair of triangles that look a little more complex, but still workable. We're going to now find the measures of angles 1, 2, and 3. So let's start with number 1. So the measurement of angle 1, well, we've got 58 plus 90 plus the measure of angle 1 must equal 180. I'm going to subtract 90 from both sides to have 58 plus the measure of angle 1 must be equal to 90. And now I'm going to subtract 58 from both sides, which means the measure of angle 1 must be equal to 32. So angle 1 equals 32. How about angle 2? Well, angle 2, if we look at where it is the vertical angle of angle 1. If you recall, vertical angles are congruent to each other. So the measure of angle 1 is congruent to the measure of angle 2. So if the measure of angle 1 is equal to 32, then 32 is equal to the measure of angle 2. One more. So we found 1 and we found 2. Well, number 3, D, we need to figure out what that is, but we know what 2 is and we know what the other one is. So the measure of angle 2, 32, plus the 108, plus the measure of angle 3 must be equal to 180. Combine our like terms, we get 140, plus the measurement of angle 3 is equal to 180, or the measurement of angle 3 is equal to 40. So we have found all 3 of our measurements of our angles. Then, extend it a bit, what is the measure of angle BCD? Well, angle BCD makes a linear pair with either angle 1 or angle 2. So to find what the measure of angle BCD is, all we would do is take 180 and subtract from it the measurement of angle 2, or angle 1. So that's going to be 180 minus 32, also known as 148. All right, guided practice. Find the measures of the numbered angles. Well, we're going to solve this the same way we did the other one. In number 3, we want to find the measures of 1, 2, and 3. We're going to start with the measurement of angle 1. The measure of angle 1 is such that 66 plus 58 plus the measure of angle 1 must be equal to 180. Combine our like terms. Well, 66 plus 58 would give us 124. So 124 plus the measurement of angle 1 equals 180. Subtract 124 from both sides. The measurement of angle 1 is equal to 56. And just like in the previous guided practice, angle 1 and angle 2, they are vertical angles. So the measure of angle 2 is equal to 56. Lastly, we want to find angle 3. Well, we're going to do the same thing as we did before, because the measure of angle 2, 56, plus that 50, plus the measurement of angle 3, must be equal to 180. We're going to combine our like terms. 106 plus the measurement of angle 3 must be equal to 180. Subtract 106 from both sides. The measurement of angle 3 must be equal to 74. And now we have found the measurement of angle 1, the measurement of angle 2, and the measurement of angle 3, all from knowing that the internal angles of a triangle are 180. Let's keep going. Number 4, we want to find the measurement of 1 and the measurement of 2. In this one, it doesn't matter which order we do them in, as you'll see something funny in a little bit. So right off the bat, we know that V here is a 60, this angle WTU is a 30. We know that this angle here is a right angle, which means that by definition of a linear pair, this must also be a right angle. What do you notice there? Let me redraw it for you. It does say that we have a triangle divided into two with two right angles at the bottom on opposite sides. And I know some of you might be thinking, oh, that looks kind of like the Deathly Hallows symbol from Harry Potter. But no, that's not this at all, okay? What else do we know about this triangle? This here is a 60. This here is a 30. And then we're missing this angle up here, the 1, and this angle here, the 2. Well, the internal components, the internal angles of any triangle must equal 180. So if we look at this from working angle 1 first, we have measure of angle 1 plus that 60 plus that 90 is equal to 180. Combine our like terms. The measurement of angle 1 plus 150 is equal to, getting ahead of myself, 180, which makes the measurement of angle 1 equal to 30. Meanwhile, if we look at this from the other perspective, from angle 2, well, 30 plus the measurement of angle 2 plus 90 equals 180. 120 plus the measurement of angle 2 equals 180, which means the measurement of angle 2 is equal to 60. Oh, look. This angle here is the same as that angle there. They're congruent. This angle here is the same as this angle here. They're congruent. What we basically have here, folks, and we'll talk more about this later on, are a pair of congruent triangles that actually reside in a larger equilateral triangle. But more on that later on in the unit. Just a taste of what's to come. All right, last page of notes, folks. The exterior angle. At each vertex of a triangle, an angle formed by one side of the triangle and the extension of the other side is called the exterior angle. The exterior angle theorem, which we talked about yesterday, is such that the measurement of angle 1 plus is equal to the measurement of angle A plus the measurement of angle B. That is to say that this measurement here is the same as this angle plus that angle. Again, folks, there will be a video proof in the folder, and I did a proof of it in my video yesterday in classifying triangles. But taking this into account, let's find the measure of angle 1 here in this example. Well, if we have a 60 down here, if we have 60 down here and 80 up here, well, 80 plus 60 is 140. The entire area here must have a degree measurement of 180. How do we get all this to be 180? Well, to have that be the case, this angle here has to be equal to 40. This angle here is the linear pair with this angle here, and this angle here is the same as these two angles combined, which means that angle 1 here is equal to 140. Example number 2. We want to find x. So we know that this angle here is the same as this angle plus this angle. So we can actually set that up in an equation for us, such that we have x plus 55 is equal to 78. Subtract 55 from both sides. X is going to be equal to, what is that, 23? Yeah, x is equal to 23. Two-step problem. Just by knowing that this exterior angle, PQS, is the sum of angle S plus angle R. All right, last 2 guided practice problems. Find the measure of each numbered angle. All right, so number 5, we only have one angle to find, but let's set it up. We have 50 plus 65 must be equal to the measurement of angle 1, as it is an exterior angle. So combine our like terms. 115 must be equal to the measurement of angle 1. Number 6. There are actually 2 ways we could work this out. We could work it out based on internal angles of the triangle or external angles of the triangle. Either way, it's going to come out to be just the same. But for simplicity's sake, I'm going to use the exterior angles of the triangle, simply because I like to add more than I like to subtract. So exterior angles of the triangle, we're saying that 25 plus 35 is equal to the measurement of angle 1. Let's say that 60 is equal to the measurement of angle 1. Well, if the measurement of angle 1 is 60, and angle 1 forms a linear pair with angle 2, that means that angle 1 plus angle 2 must be equal to 180. So the measurement of angle 1, 60, plus the measurement of angle 2 must be equal to 180. Subtract 60 from both sides. The measurement of angle 2 is equal to 120. And that, folks, is the extension of the notes for today. We'll have an assignment tomorrow on this material. Take care and ask any questions you might have about this material if you're getting stuck.